Hey, good afternoon, everybody. We are back here on the workbench again. All right, so it's been kind of a crazy week. Unfortunately, not much has been accomplished. Part of that has to do with work in general. But I figured we'd go through here. Notifications that I'm live. I know that. All right. Anyhow, so in the last video, I was going through and trying to show you guys, in a very quick rudimentary format as far as how to check non-polarized capacitors for the shield side or the foil side. So that's kind of where we're at yet today. I've got some capacitors I've already got laid out over here. These I've actually got pulled for one of the jobs that's coming up, or that I've been kind of halfway working on. So set these off to the side. Hit my hand with a hammer yesterday, and it is sore. But anyways, hey, 3, what's going on, buddy? Oh, you're back in Florida. Oh, okay. I didn't think that was going to be for a few more days yet before you took off. Well, anyways, I drew up a rudimentary schematic, and hopefully this will help some of you. Now there's another set of contacts that are in here that I've got drawn. This is actually where I'm going to be adding an LED at a later time, as far as to be able to flip, basically I'm going to build a flip-flop circuit as far as so that I don't have to manually put the part in and out. Yeah, well, I hit it good right in here. It slid off of the pin that I was driving, but just one of those things. One of the hazards of doing what we're doing. But anyways, I figured we'd go through here on the schematic real quick and show you guys as far as in relationship to what we're actually doing, and then you can kind of go from there. Now, in the previous, in the previous video, I didn't have this part added. All we were basically doing was just going off the probe, which does work, but it's very, very hard because you can't get quite enough reading. So since capacitors, even though they may set for 6 months to a year, even in a small 100 or 50 puff capacitance, as far as on small capacitance, they can still have a little bit of residual in them. The other side of that too, since we are checking this with, I think I've got the scope set at like 20 millivolts. You're still going to actually have a small charge that is going to be filling up on the capacitor, which doesn't give us quite the reading we need. So we needed to be able to make sure that it stays 100% discharged, no matter in which format or flip-flop that we do. So what I did was I actually built this circuit, and all 4 of these diodes are just a standard 1N4007. You can use something as simple as a 1N914 or a 1N4148 to do the same thing. I've just got a plethora of these, so that's the reason why we went ahead and just use those. Plus, they're a little bit bigger and easier to put down onto the circuit board. So what it amounts to is these 2 here are going to go directly to essentially where our capacitor itself is going to be tested. And then we've got our leads that are coming up and testing each side. So in theory, this is on both sides, because right now I don't have this set up with the coil activated as far as on the relay. Eventually I will, and to go ahead and reduce some of the pickup that you're going to see as far as that's on the scope right now. this actually will need to be mounted into some type of a metal or shielded box, which I'll get to probably this spring. But for now, it does work, and it works pretty good. So I wanted to go ahead and show you an update on that and show you which side is actually what they call the foil or the shield side of a non-polarized electrolytic, or non-polarized capacitor. In this case, we're testing silver dip micas. All right, so let's see if I can get the remote here. I want to try to get everything all in one shot. So there we go. All right, so this is one of them that I've already got marked. You're going to see the blue on the one side. Now, the way I've got this set up, the center leg is what's actually going to show us our shield or our foil side, the side that the leg that's hooked to the outside of the internal structure of the capacitor. That's the side that we're concerned about, because that's the side that's actually the shield or foil side. So, that's one of the things we're going to do. I just took some header pins is what I did for test, just to be able to plug it in. I had a broken one in the tray, so I went ahead and just used it, and it's enough to get through here. Eventually, I'll go ahead, once I get whatever container I'm going to put this in, I'll go ahead and I'll actually mount this ZEP socket, and then that way I can go ahead and clamp down on it, and then we can go ahead and induce essentially noise from the body itself through our fingertips through this. So that's just one of those that I try to keep a couple of these on hand just for odd and end things like this. So, all right. So right now I've got this set at 20 millivolts on the screen. Like I said, this one's already pre-marked, so you're going to see that the spectrum analyzer is dancing quite well right there, and that tells us that we're inducing the noise on the outer shield. Now, if we take that part out, we plug it back in, and we go ahead and grab that. I'm giving it a little twist to make sure that I've got good contact. You're going to see that essentially it's low on noise. So if I pick it up off there, that's the reason why a shielded box is actually going to be best. That way we can take some of that ripple that you're seeing there out. But your higher inductance or noise that you're picking up on the scope, that tells us which side is the shield side. So again, because I've got it hooked to the center lead of the coax, that's what that's telling me. So I figure we go ahead and grab a couple more here, because I actually need a couple of these as well for the amplifier that I'm going to be working on here over this weekend. They actually, provided I actually get this weekend off, they're really pushing hard for us to work all the way through Thanksgiving, which was not the case just 2 weeks ago. So there's a lot of times in this, just because it's got writing on the face doesn't mean that which side is which. Okay, so not picking up anything there. I'll turn this around. Now we're picking up our signal, which is being transferred from the outer shield to the center of our coax, which means that is the foil side. hardly pick it up, and I'm left-handed. All right, it's got some stuff on it here. But oftentimes corrosion or what have you gets on the ends of these, and or in some cases, like with this batch here that I got, these were all on the tape, on that tape reel. So we kind of want to clean that and see what we've got. All right. So we don't have any noise there. Put that back in. Get a connection here. Down in there. Put that back in here this way. And there's our noise again. So anytime you get anything on the leads, like I said, it's actually important to make sure that you get any of that off of there. It's definitely made it a little difficult. You know, sometimes it's corrosion, sometimes it's oxidation, which oxidation is a type of corrosion. But to help eliminate some of this, that's part of the reason why I've got that other socket that eventually I will go ahead and utilize. That way I can actually bite into each one of the legs. So since I know that we've got the noise level that's there, so that tells me that this side is what we're looking at. Just because we've already done several prior. So I'll mark that one. Now, since these came down or these were on a reel, chances are good they're all going to be the same. But I'll get some here in just a minute that's not going to be the case. We'll just go ahead and do at least one more of this particular value. And we've got about the same reading there. So I'll turn it back around. Plug it back in. Move it around a little bit in the socket. There we go. But I know where some people have had difficulties with some of the amplifiers and some of the other circuits that they've built here over the last, you know, 3, 4, 5 years, because of the components that we have that are available to us right now. Some of them aren't quite as good as what they used to be. Some things are better, some things are not. But this is just one way to kind of go ahead and kind of combat and help alleviate some of that. So I'll set those off to the side. I only need 2 actually of those, so I should be able to get a decent match out of those. And this should work for most, for most applications. Let's grab. Go. Because I know I got these in, they were all loose. Okay, so again, since we know we've got noise right there, we know that we're already on the shield. Since I know this side right now is going to be our center lead, so that's going to be the shielded side, the outer foil. That's the side that we want to take and put directly to ground. Okay. Go ahead and turn it around anyways. Don't have anything. Turn it back around this way. Now, just out of these 2, see if we can't zoom in on that. Focus camera. It's hard to see through the bifocals and see if that's clear. Anyways, this side's got the writing on the face. This side does not. It's on this side. Make it a little easier to see. You can see they're both. Like I said, it's hard to see whether or not the camera's in focus or not just because of the bifocals. But let's change some of the lighting here and see if that helps. What we're after anyways is to get a clear enough picture. So essentially back to back. You guys can see which one's got the writing, which one doesn't. But we'll do a couple more here real quick. Okay. Turn it around, the noise should go away. sure my fingers aren't on the leads either. Okay. So, noise that way. Turn it back around. Get it down to that socket. Okay. So mark that one. So we've got noise on it that way. Even more that way. So since we've got the highest level there, put that back in. And this is the reason why it's really important to actually have this in a shielded box. The way it doesn't pick up anything extra that it's not supposed to. Okay. Looks like we're at 50%. Half of them are one way, half of them are the other way. So let's check one more. But yeah, when these come down the assembly line, like I said, they don't matter which way they flip whenever they go to get the actual writing put on there. So got a reading that way. It's always best to turn it around too, just to make sure, because sometimes the foil is pretty thin. And again, it also depends on how much capacitance. Now these are 160. I don't use these very often. Okay, the other way yields us the most noise. But just something that I've been kind of testing out and playing with a little bit. Like I said, just to be able to build bigger and better products. You know, in some cases it doesn't matter. In some cases it does. For example, if you're dealing with an old receiver, it actually does make a difference, especially on what they call the wax style capacitors. Those are a little harder to come up with as far as on knowing what's what, especially when you're having to replace it with the newer stuff. Those were typically the old ones. Those were marked with a banded end, so that you knew, even though it was non-polarized, it would let you know as far as which side actually had the outer shielding on it, so you knew how to go ahead and place it within the circuit itself. So it looks like we've got 3 with the writing up, 2 with the writing down, as far as for the to show us or indicate which side is actually the shield or the foil side that goes over top that's attached to this one side leg versus the other. So zoom in here a little bit. It probably would depend on the circuit itself. To be brutally honest with you, ever since we came out with the HG transistors, and that's the whole thing is the HG transistors. Most of the builders, if they will tell they'll tell you up front, well, every box is different. Well, and that is true. Even though a lot of the components are the same and we're using a lot of the same values, it's something that we've all combated as far as some of the different issues. So, depending on how big the amplifier is, it can cause a lot of harmonics. And that's one of the biggest things that, we've all combated, had to combat here over the last, 4 or 5 years, since we've all had to, go to a different type of transistor. They don't have their quality or their QC down to, down to the level that we're used to. As far as things being a little tighter, for example, your Motorola's, they were very stringent as far as on, what would or wouldn't pass within their parameters. So when you start opening up your parameters on, your main transistor, especially when you're dealing with RF basics, well, stuff like this now has to come into play in order to go ahead and help combat some of the irregularities that you're seeing in other places. So, it's one of those where, we have fought and fought and fought with this for years. We'll get 2 or 3 months of great transistors, and then we'll get some that they're still, they still work, they still function fine. But now we've got, this small little issue here, this small little issue here, and a lot of it has to do with the harmonics that you see. And it's one of those little hidden things that not a lot of people are talking about. As far as on how to combat some of this, and there again, I know that there are several of us out here that we have come across that. The spectrum analyzer has been an absolute awesome tool as far as to use. 25 years ago, I never did bother with a spectrum analyzer. I'll be brutally honest with you, but it wasn't as big a necessity. For the most part, you could look at your oscilloscope and you could pretty well tell, if everything was still in tune and would do what you needed to do. Moving forward, 20 years, obviously now things have changed, perimeters have changed, what people are wanting has changed. That's the only thing that has stayed the same in electronics is everything changes. So because of that, we also have to, evolve as well. And that's what this is it's a type of evolution. Not to play on the amplifiers that, I've started building here this last year. But yeah, that's just it. I mean, we're all going to have to, keep moving forward as far as in learning more and more and more. And it's just like these components here that we're dealing with now. This is, 40, 50, 60-year-old technology that is still being used today. It's very hard to actually compete in many respects because of how these are made and what they're made out of as far as on the quality and things like that. It's the reason why we're all still using a lot of, a lot of the silver dip micas and things like that. Now, they're again going into, and right now, since there's still so much of this out there and it is still being produced, um, now we're moving into, other types. Um, I don't have any what I would call really good um, RF capacitors that are in the 1,000 microfarad. Um, like I know there's a couple of builders that are using the SMT 1,000 puff caps. I haven't been able to find any at a lucrative price to be able to purchase. Now I have had, as far as on some of the smaller ones, and that's what I'm looking here for. Here we go. Now for some of the circuitry, and again, this changes a few things as well, which is going to the SMT or SMB technology. Let me remote here. Now this is, and I use this actually in a couple of different portions of an RF circuit, but this is a 10,000 microfarad capacitor, or 0.01. I think that's right. I said that. Yeah. 103 at 0.01, 10 nanofarad, 10,000 puff capacitor is what this is. Okay. Well, these are as well. Let's get this back into the frame here a little bit better. Huh. I can change the cycle time on that. Cool. Learned something new about my camera. Yeah, I think he's used that maybe 5 or 6 times, Gary. I know right now he is selling a horde of stuff. I mean, he spent several years where, I mean, he just kept buying and buying and buying and buying. So I think what he's trying to do is reduce down some of it, and looked at what he's actually using versus not using. So, like I said, I mean, he has got one heck of a collection, but yeah, but both of these are actually the same value, even though they're 2 different sizes. And these are actually set up in layers. So, and granted, the other stuff is actually set up in a type of layer, but essentially the outer portion of it is, or skin that's underneath the mica dip, is the fact that it's more of a wrapped shield around it as far as that goes, versus where this is actually put in layers this way and then physically cut, and then they put ends on the capacitors themselves. So, and these are great just because of the fact that you have less lead. Now, less lead means less inductance that's actually on a capacitor. So, depending on the circuit, by changing the length of the lead here, put that one on there, but essentially this little piece of wire, depending on how long you keep this, actually will add a small amount of inductance into the circuit versus the amount that this would add. When all you're trying to do is just add capacitance versus capacitance and inductance. Now, granted, everything that we do and deal with runs on inductance and capacitance. So, depending on what you're building, in some cases, and that's one of the things that I have been finding out, and you'll see, especially on the one pill drivers, I actually use quite a few of these on the input or the output, depending on where it's at. But I'll use these because of the fact that it's easier to control versus using like a leaded capacitor. Because all I'm trying to do is just add the capacitance versus any kind of inductance onto the one side. So that's the reason why you've seen in the last couple of years that I've been using quite a few of these within the circuit. The other ones I've not been able to find anything heavy enough that can handle the RF. So it depends on whether it's on the input, the output, and where it's at in the circuit. Some of these will work great because of the fact that it's kind of strange that there's no, there is RF on the input, but it's using the capacitance more or less as a coupling, versus part of the RF. It is part of the RF circuit, but it's not, if that makes any sense. So you can get by with like the larger ones like what I use there. Those are rated for 100 volts versus 300 to 500 volts, or in this case, this is a 330 that's rated at 1,000 volts. So again, part of it has to do with size, part of it has to do with voltage ratings, as far as, or the construction of the capacitor itself as to where we can use it at. Although these are set up for RF, because of the fact that they don't have a high rating on voltage, they work well on an input but not on an output, just for an example. There are some that are designed for on the output side. There again, you're going to see the physical increase in the size and diameter of the SMD and SMT parts that are being used. So eventually, probably within the next 15 years, this will pretty much be the standard, and stuff like this will finally dissipate. But at that point too, everybody's going to be able to print their own circuit boards and what have you. That stuff, it's coming down. That's something that I've actually been looking into as far as on, some of the different printers and what have you for circuits. Again, just trying to get caught up on everything else before we go into the next, evolvement. Some of the things I'm looking at, are another $4,000, $5,000, $6,000 for here in the shop. And that's part of the other reason for the add-on, so that I can get more stuff out of here and get more, more equipment that is going to be needed for, some of the different circuits that are hopefully to come. Granted, there is some outsourcing that's available as well. Unfortunately, I don't have the programs to actually do some of that as well. But yeah, that little one pill, it's a killer little one pill or two pill that's in the Cobra 2000. If I remember right, that one has Toshiba's in it. Going back to that, I was actually kind of surprised that he was asking as low of money as what he is, just because of what it's been built with. It does have automatic sideband, which, it was set up for just what it is, a Cobra 2000. It's got a little variable underneath of it, so you can adjust the carrier there too. Just plug the speaker in the wall, run your little jumper over from your radio over to the amplifier, and then you're ready to go. But it's actually a really, really neat little project. I've been wanting to do one in a like an old Uniden President or Uniden type speaker. I've been wanting to do one of those here for the last few years. Just had never got around to doing it. Had a couple of customers that have asked me about doing one, and I've just not had one come in yet. So eventually that will be one that will be made as well. But no, like I said, just wanted to to give you guys a quick quick little update as far as on that. Um, like I said, you can see some of the noise that's being generated just from, off the board or me touching the back of it. And a lot of this noise, like I said, can be eliminated once this is actually put into a box. I'm just trying to get through one of the projects in particular. I'm just touching the top of the relay right here, but I'll actually come back and I'll rebuild this circuit, and I've got them on my list right now that I'm building as far as for my next order from Mauser. They've actually got some electronic switches. They do add a little bit of resistance to the circuit, but um, you know it's going to be a lot more compact. It'll use less energy. This one I'll probably still go ahead and finish this little circuit here out, and just put a little toggle switch on it. But I am going to put some LEDs, that way you don't have to keep taking it in and out of the circuit. That's the whole reason why I originally put a relay on this board, is so that I can go ahead and put, like I said, I'll probably put another relay over here that'll drive a couple of LEDs to let me know, okay, well, you're on the center pin here, as far as, or shield, mark each side, one for shield and one for the other side. So whenever it's lit up, it lets you know which side to actually mark for that. But like I said, just a simple little circuit. It still works even though it's, in an open format like it is. It's just to go ahead and kind of help, the next person out. Like I said, running my finger across the back of it. Like I said, and I'm not even on, I'm actually on the ground side right there, that I'm picking up. So that's what you're wanting to try to avoid. It's the reason why putting this into a metal cabinet will actually be in the best format at a later date. It's just wanted to try to get through this and let you guys kind of see it's a very, very simple circuit. You don't have to have anything. You don't have to have this relay. All you need is a point of contact for your coax, and 4 diodes really is all you need in order to go ahead and create your own. And you can do that. Here's where the older type oscilloscopes actually kind of shine. You can use like what I've got here as far as the digital oscilloscope, and this is not an expensive one. It's made by Handtech. I bought that one actually for the use of just testing components, because of the fact that I needed to be able to use the X and Y and to change to go over to the 4-channel. I didn't want to have to constantly change everything from oscilloscope to oscilloscope for every setup. I've got a box back there that I built several years ago, and that's what I use it for, as far as to be able to do in-circuit testing for like Xenier diodes. It works okay for certain capacitors, but if they're too low in value, it doesn't give me quite the reading that I need. But it does help as far as reduce, some of the parts pull out, in order to go ahead and check to see whether or not I've got, the different values and that they're actually functioning properly in the circuit. But all right, guys, don't want to spend a lot of time here. I've still got a lot that I've got to try to get done anyways prior to going to work tonight. And like I said, if they have their way about it, I will work all the way through even my scheduled weekend off. Of course, they've offered me triple time if I do. So that's looking real good, and it's kind of hard to pass up. But that also means that I'll work all the way through until Christmas. So, all right, guys, I appreciate it. Like I said, just wanted to touch base with you. Bruce, if you popped in here, capacitors I've actually got set off to the side are actually 4-year amplifier. So we're going to do a tear down on that. I won't get too much done on it tonight, but I am going to start back in on yours. I've got John's Cobra 148 that I'm still finding wires that aren't attached to anything on the circuit board. So, I've set that off to the side. I'm going to try to get Bruce taken care of and then go back to the 148. Ran into some issues with the clarifier modification, and I think that has to do with some of the wiring that is off, because I keep coming up with two or three wires that I'm not sure where they need to terminate at. A couple of cut parts that did not anticipate. So, even though it all functions, if you try to make any changes to it, it doesn't want to work. So, um, like I said, we got to figure out what's going on there and get that taken care of. But guys, I appreciate it. Like I said, I just want to come in here, make a quick video, show you a few things, and kind of go from there. I hadn't planned on being out here for 45 minutes as far as on this tutorial, but hopefully you guys found some good information. You guys take care. God bless. We'll catch you on the next live feed.